Hello. I thought I was going to be able to get something done a little bit quicker than I was, so I'm going to have to spend the first couple minutes of the stream here trying to get that working. I'm working on tweaking a version of the YT Chatmon stuff for the GUI here. You can see stuff's a little bit janky. It says can't read the chat window, so I got to fix that before I can actually get the stream going. Bear with me. If it's going to be more than 15 minutes, I'll just do a git revert and work from there. But if it's not, then we're good to go. So let's hope for the best. Right now I'm getting some sort of weird problem with can't parse the JSON stuff. Sorry guys. Hello everyone. So we're actually probably going to start a little bit more proper in a couple minutes, but let me see if I can get this bug out. Well, it gives you time to get familiar with the data you just posted. Excellent. Yeah, I'm glad some people are starting to see that. The data is really, really cool coming out of this FX3 right now. The emojis will not show up in the thing that's normally operating. Right now I'm just doing something a little bit different until I get this actually going. Also, let's try to get color chord up. Oh, that's right, pseudo. Okay, so now we got that up and running. Okay. Still got to get the chat working. Getting some sort of weird corruption bug. Yeah, I've never seen an error like that. That's just great. The FX3 does not have SIGROC compatibility, at least not yet. I tried getting a SIGROC to support it, but they were like, well, we can't redistribute binary blobs. I'm like, I built it myself. I have all the source code available, but they still don't like the idea of having to distribute binary blobs with their thing, even if it is open source. So I don't really understand the logic behind that. And so, I mean, I don't know. I don't really have the ability to go deal with that right now. I can't really. Okay, seriously, what is this thing doing? That's what the problem is. Gonna work? Still not doing anything. That's broken. Fatigue. Okay, such pro debugging, very well. On the HUD, yes, it is definitely dead because I don't have this working yet. Almost got it. Almost. Then we can actually get the stream started proper. Okay. And it's going to be writing into gonna work? Hey, okay. Where is the API key? Goose and P? Am I showing the API key somewhere?
Very top and then define.
No, that's just the live chat ID. I don't think I showed the API key.
I think that's probably.
Let's see, would it be in this maybe? These are just E tags.
That are hashes.
Yeah, but all these are just IDs of the messages or like the live chat ID. Yeah, Goose, if I did show an API key, please let me know and then I will swap that out. I don't think I've shown one though. I don't see anything that quite looks like the API key. Okay, well, if you think so, give me a heads up, and I will go fix that. Let's see, is the stream updating? It's not updating. Why is the stream not updating? Oh, you know what? I know why it's not updating. Oh wow, crashed. That would also be bad. Still can't val grind it, so I don't know what's going on. Man, what the heck? Huh. Nope, still bad. What is going on? Okay. Yeah. Test. Again. Please crash. Come on. Crash. Neat. Crashed. Oh, great. It's like the worst place to crash. Bummer.
Yeah, I mean, they're kind of fun, but like, I can't play them all the time. Apparently, that's where David's cash guys. It's just like a head is like they will buff the battleships over other things and hurt other things to make the battleships more effective.
Testing again.
There are far fewer historic ones. I only see one or two usually, and sometimes just three. I've been like half a player historic.
Yeah, I don't know what could possibly be causing a problem here.
I'm gonna try the green one just to see what I can make net, credits. This is fun.
Man, I gotta stop doing this whole editing stuff right before the event.
I need 5 million credits to get the base, and I have 2.5, so. Can sell some stuff, but.
Like, what does that even mean?
Probably.
Just throw in more G's, maybe that'll help. Nope.
Somebody asked.
Am I doing something weird with the request?
Somebody showed our
I don't know why that would fail.
the range of seconds.
Okay, that should fix it actually. I tried mallocking something that would be 0 bytes mallocked, and that does not work. Okay, Valgrind still doesn't run, but hopefully this works. Oh. I really hope that that's what fixed it. Okay, last test. Test. Okay. Boom. Moob. Okay. I think we're golden now. Oh, there's an extra printf. Good, now it's no longer printing the extra stuff. Okay. let's go now. That was totally a... Okay. Now we're actually starting the live stream. Thanks everybody for tuning in. It is 15:51, so that is about 20 minutes after the thing actually started. And I guess I'll show you guys what I am up to. So, let me get some...
Flicker.
What?
I said, ooh, flicker.
What's Nicker?
Flicker.
Oh, Flicker, yes. Let's see, can you see that more clearly now?
I thought it looked better without the light, to be honest.
Yeah, but I want to show what's... Okay, so what we actually have right here is an FX3 hooked up to the Lighthouse thing, and I'm probing some of the pins on the Lighthouse right there in order to just kind of yoink the data off. Wait, you said sig fault? Oh, no sig faults, all good. And so we're pulling the data off of the Lighthouse and trying to decode it. Now, previously, I actually had a lot of problems with that. I don't know, it took me a while because, like, I still don't own a Sele, and the goal was if Sele could actually decode it with the really awful Manchester coding data from the not Sele I was using last time, I would go buy a Sele, but that didn't happen, so I still don't have a Sele. Instead, what I have is this FX3 board, and I've been capturing data with it. What I've actually done is gone back and, ooh, looks like somebody is messing around here. Crud. R2XOT. Looks like something is wrong, he says, every 16.384. I don't know about that. Let's actually take a look at some of this data and take a peek at it. So first, let's actually just capture some new data, because that's fun. So get FX3 fun, CD superflash, or actually let's pull. Get pull origin master, get checkout origin master, or get checkout master. Pull, get checkout master. Am I up to date? I'm up to date now. Okay. Superflash. Let's reseed the FX3 here. And let's go capture some data. Just so you know, oh wait, Peter, you got something interesting? Demodulates into pretty graph and CSV. Yes, please, Peter, go upload that. And yes, Peter, the new data is 8-bit data. Turns out one of the problems was every 8192 bytes, I'd been sending like 16-bit data, so it was actually dropping like a bunch of the stuff. So the data I was posting before was completely trash. Don't use that previous data. FX3 view. So now we actually are getting data from the thing. Let's record about 8 seconds of it. So this is the total number of megabytes we've recorded so far, and boom, we'll call that good. Now, what I'm going to use is HXD. Do I not have HXD? Or not HXD, what is it? Bless. Let's use Bless. Bless is pretty good. I was using HXD in Windows to do some of the, like, just peeking at the data. So we'll take a look right here, and it looks not what I was expecting. Oh. No, I don't want to open that. I want to open this data file. So if you get it lined up nicely, let's get a nice little, everywhere that FF exists, we'll just display that. So as you can see, the data actually is demodulating pretty nicely. You can get these nice stripes of where the data's like kind of lines up. Let's see if we can find a better orientation of that. Oh yeah, look at that. And so you can see that the data is kind of making these nice stripes. So it means that the data isn't being corrupt. Now, Peter, you mentioned something about there being something bad happening at every 1684 bytes. I have not actually looked at that particular boundary yet. So let's take a peek there. So let's go down to, oh boy, there's entirely too much data here. So 16384 is 0x40000. So let's take a peek. That would be somewhere in here. But like just visually looking at this data, it seems like it's still in line with the existing paths. So like what you can see are these kind of geometric patterns that are occurring inside the data sets, where like you can see that this path kind of continues on, and it's continuing on over that 16384 boundary. So I'm inclined to believe that it works pretty well. So MCD is suggesting I use Oketa, Octeta, O-K-T-E-T-A. Sudo apt-get install O-K-T-E-T-A. Ooh. My password is visible if I type it like that. Thankfully I didn't finish it. There we go. I just mistyped it. Oh, Root. Root, you were the one who found it? That's kind of cool. Octeta. Let's take a gander at this. Whoa, what just happened? That was weird. So this is Octeta. I have never used Octeta, but I do appreciate that they use a one of the code pages where you can see FF and EF. But I can't. I don't know how I would use this to be useful. I think that it's a lot easier to see in the other one, unless you know something about how to use this tool that I don't. Yeah, I'm not sure how to use this tool. Uh-oh. I don't use XFCE, I use Mate. But it looks like Octeta is now hosed, so I'm going to go kill it, maybe? Let's go back to not Octeta. So back here. Let's try to find and see if there's, I mean, I don't know. To me it looks like there's not really any problems with the data set. I could be wrong. But it looks like the data is pretty much continuing on nicely between the data sets. The other thing to consider is if the data was actually hosed. Oh, so okay, I posted a picture to Twitter a few minutes ago, and inside the picture, what you end up getting is this glorious valley of no data points. And the reason that that's so important is if there was corruption in the data. Okay, so let me explain what this picture is first. What this picture is a histogram of the length of the runs of all of the data. So the idea is that if you have, say, 1, 2, 3, 4, 5. I can't even count that. I'm half blind. 1, 2, 3, 4, 5, 6, 7 points in a row. Then what you end up getting is a peak at 7, or is it 8? Can't really remember how that works. But point is, you end up getting a peak at one of those points. And so by having like this data check out that way, so that you actually don't have any data points in here, it means that there aren't situations where you've missed or corrupted some data. Peter, take a couple minutes. We have another hour and a half before I got to stop the stream. So I'm still just kind of going over the data that we have so far. So yeah, feel free to take some time, Peter. Let's also have a little bit of stuff that's helpful. CD, get ESP tracker. Do I not have ESP tracker? Huh. So what I'm going to do is pull in that data file. I'm going to delete it from here because I don't have that much disk space. And so this data file right here, I'm going to run with something I wrote called fx3 process. And I'm going to process this so it counts the number of situations where you get a certain number of ones or zeros in a row. Histogram.csv. So right now what it's doing is it's going through the file and it's systematically looking for like one, so like right here it would see 1, 2, 3, 4, 5, 6, 7, 8 in a row. So it puts a dot in the histogram for 8. Or 1, 2, 3, 4, 5, 6, 7, 8, a dot for 8. Or this one has 9 in a row, so we put a dot at 9. And so the idea is if there was corruption, so like let's just say that one of the files was corrupted, let's say on like the 2048 boundary. So 2048 would be, or not 248, let's just do the 16384 boundary. So that would be at 4000 hex. And so at 4000 hex, say, actually we could actually corrupt the data file and see what that would look like, and then we would know that something was wrong. Sorry. Oops, that data file is weird. I just want to make sure the data still looks good. Yes, the data still does look good. So what I'm going to do is I'm going to deliberately corrupt the data file just a little bit. So let's say right on the boundary, I'm going to have right here, let's say this happens. And I'm going to save this as so hopefully, unless, like, we're also just validating my tools, because I just wrote this earlier today, I could have had a bug in it. But what I've done is I've made a problem where 1, 2, 3, 4, 5, there would be a situation where there would be 5 of the same value in a row, which is going to be bad. It's not going to be a valid thing. So if we open that data set then, what we should see is, Maybe my histogram tool isn't working. Huh. Other file? Oh, histogram bad.csv. Gotcha. Cool. Right here, you can see in 5 there is a situation where there was a bad data point. And so that's how we can tell that something's wrong with the data capture. But the fact that we don't have those means that maybe there's still something wrong. It could be like at the boundaries. It could be like maybe 1 byte is missing. And I still don't necessarily know. I've never been able to vet to make sure that 1 byte isn't missing at the boundary. But it gives me a lot of confidence that this is actually doing okay. One of the other notes is you'll see that there's a lot of situations where there's just a single bit flip back and forth. That's probably due to ringing on the line. So that's probably just because instead of having like a nice controlled situation, I just have these wires kind of hanging out and going into the FX3. So Peter, you said that your filter is working out too, so it looks like we at least have some mechanism to finally capture data that's good. And good thing about that, it's cheap as dirt. So that's awesome. Let's see. Let's not process the bad histogram anymore. Oh. Does anybody know if Root is in here yet?
Just give you comments.
No, that was Peter, wasn't it?
Thank you. Just about 5 minutes ago.
Yeah, but that was, I don't know if Root's watching. He, I don't see him making any comments. I mean, I thanked him on Twitter. Let's hope he noticed. Let me get him on the stream, man. Oh, really? Okay. Let's see if we can get his... Don't think you can. Okay. So point is, Root is here. So I'm glad that he hopped in, got that. Let's see. He did notice that there is something weird every 16384. It is possible I could be skipping 1 to 2 samples every one. Let me make sure he gives that back to me. At Root, is there any way you can give me your code so we can test against that when I capture the data? I can still try a few different things within the FX3 GPIF engine to avoid any missing samples. One of the other things I did want to point out is that when you're trying to do sort of like locking onto stuff like that in microcontrollers where you really don't have a lot of time, you rarely use something that's really truly like a PLL. A lot of times you'll kind of make a state-based system. So the idea would be if you see a pulse of this length or this length or this length, you just kind of work with that and say, okay, well, then that means that the state is this, the state is this, and we can go from there. So maybe it would make sense to start trying to decode the data directly. So he was saying Manchester, try Manchester. I think they said it was Manchester. It covers a good-looking 12 PLL 12 megahertz. This recovers a pretty good-looking Manchester-coded bit stream. Okay, so it's clear that his thing is a little bit more sensitive to the potentially missing samples every 16384. Wow, actually, I see exactly what he's talking about right now. So if I wasn't missing any bits periods, you would expect these should be lined up perfectly. That's actually kind of cool. I like that. That's a neat visualization. So I guess I'll get started with my own processor, and we'll see if we can do it. So let's first, alright, why is it crashing? So if it is truly Manchester, so that's a long. So long, short, short, long, short, 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 long, long, short, short, or no, long, 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 short, 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 long, schlong. Huh. So what is differential Manchester? Because I know that came up at one point. Somebody had mentioned it. It makes me wonder if they're doing something that would be like the opposite of Ethernet. So the way Ethernet works is in order for you to actually start decoding the data, you actually need ahead of time to be able to sync up to it. So it requires the use of a preamble, because for them it's the clock or the data going low to high would mean a 1, or high to low means a 0. But an alternative way of doing the Manchester coding would be anytime you have a long, that's a logical 1, and anytime you have a short, like short short, that's a logical 0. I think both forms of Manchester require, whenever you have a short, you have an equal number of shorts. So 1, 2, 1, 2, 3, 4, 1, 2. So we can at least check that. Not that, if there is no change each tick, that's a 0. What do you mean the latter is correct? I don't understand. So my gut feeling is that if you see 2 shorts in a row, that's a logical 1, and if you see a long, that would be a logical 0. So it does look like most of that is paired. Differential, but so like using the term differential in a situation where you're using Manchester is hard to think through. Let's see, what does some images tell us? Yeah, see, it makes it really hard because you don't know what is the phase of the incoming signal. Oh, okay. So it actually is what I thought it was. Cool. Thanks, Peter. Sure. I'll go write a little. I'll go parse this now. I'll call this FX3 process 2. So one of the kind of neat things that you can do when you're inside of a microcontroller, if, like, say I want to do all of this processing on the ESP8266, it does totally have enough horsepower to do that, I think, because you can easily do Ethernet in software on the ESP8266, like bit banging. So I don't see why it wouldn't be able to do this. So let's at least start writing the code thinking about that. So what I'm going to do is I'm going to write a function that's going to be handle transition. And this is just kind of the logical way you would start working through this sort of problem. Len of run. And we'll have this thing right here be called anytime the value inverts. So handle transition cur run. Okay, so let's see here. If len of run is less than 2, all right, so let's just say it's less than 3. Let's take a look at the that histogram again. Okay, so if it's less than 3, these would be considered kind of runt pulses or something like a glitch. And so we're not going to actually count them, but what we will do is just treat them as part of the actual signal. So static int run len equals 0. See what values we would just get if we were to just give this a shot. Ooh, that's wrong. Okay, so we get a whole bunch of situations where we get a 17, 18, 18, 17, 8, 9, 17, 16. Okay, so that's really good. So we have something that's really clear. So static int. So by the way, just so you guys know, the reason I'm writing this function this way is what we can actually do is create a table that will contain all of the logic within this function. So instead of having to actually execute all the if statements and everything, we can actually run the entire function all at once in a single lookup. So on the ESP, it actually works out to something like 4 clock cycles. You can go basically execute an entire function with tons of logic. So that's why I'm like really going after that right here. So let's see. Run len. Next one would be is short. Or I guess that should be was short. If run len is short equals run len. Let's say 5, 6, 7, 8, 9, and 10 is greater than or equal to 5, and run len is less than or equal to 10. If watching, leave a little. Cool. So you sent me your demodulator. Now, just so you know, Peter, I'm probably going to use yours, but I'm still probably going to also write my own because the style that I need to get this to kind of fit in, so I can get it to do the whole like running inside a lookup table thing is almost certainly going to be different. Plot basic. Oops. Oh boy. Ooh. You write code like me. Oh my gosh, actually, you basically are writing this a lot like the way I would do it. What is your background, Peter, that your code looks so much like mine? It's so glorious. Let's see here. Huh. The last data that I dumped? Do you mean the one I just dumped today, or like the complete trash that I dumped when I first did this? The one where I totally messed up the FX3 bus? Oh yeah. No, totally. Just let's forget that that first data set ever happened. You know, I'm probably gonna also
Did you make more credits with the Eagle? Last year. Alright.
I don't know what I wanted to do.
They call the Eagle the Eagle. Franchise.
Nope, I don't know what Nexus terminal font is. I will notice there is one difference between Peter, your code, and mine. That you do use like specifically int32, or you define the type of the size for loop iterators. I used to do that, and I've kind of stopped because on some systems it actually is worse to define that, and instead just using int lets it kind of write better code. Oh, you mean what font am I using in gedit? Monospace. Just regular monospace. Take a look at what the output of your thing is. Oh boy, big document. Let's look up what these different lines mean, Peter. Okay, so the first one is time, then it is the raw data, then it is plot of the 2 points, a modulating tick behind. I don't know if I understand what that means.
There was a square off to the northeast. Yeah,
You are the oh my ZSH. I don't use ZSH. I use Bash. That's Blinker. That is definitely a solid way to do it. if you really, I forgot that that was a thing you can do. You know, I don't know if I'll start doing that myself because it's so syntactically difficult, but that is a solid way to do it. So instead of using like int for your loop variables, if you know that they need to be a certain size, you can say int fast32t, which guarantees that it is at least a uint32 and it's as fast as possible. No, there's no epiphany yet. Just things are solid and we know the data is good. We just haven't decoded it yet. Peter, give me the line for what to do with GNU plot, and I will totally give that a shot. In the meantime, I think I'm going to keep tweaking with my little thing right here. So one of the other tricks you can actually do is instead of having to like look for the transitions and all of that, you can create a function that would take on byte at a time and be able to kind of develop its own internal state of what's going on. And you can do things that are really high performance with that. So let's just keep going. If was short, emit a 1, else was short equals 1. If run len is greater than, let's say greater than or equal to 13, and run len is less than or equal to 19, then missing an underscore, which line? Oh, is this one of those things where the underscores don't always show up? Ooh, hello. That's what I'm after. Hopefully underscores will always show up now. Okay, I got GNU plot installed. That took a moment. Ah, no, it actually did say was underscore short. It's just that my stupid font looked a little weird. So anyway, actually this font is just awful. It is not the perfect VGA font. Wow, I have a really hard time with all of these. I have a degree in both computer science and computer engineering. I did a computer engineering degree for my undergrad, and then I went back to college and got a master's in computer science. I thought I wanted to do software for my life, and then I ended up realizing that I didn't. Terminus, is that any better? It's just absolutely killing me. Maybe I can use it. Actually, this is not that bad. I kind of like this font. A little bit bigger, but... You need to encode the beam as beam ID. Oh boy, hold on.
Yeah, I tell you, whenever I get spotted, like everyone just goes for me like some kind of big target, like, you know.
Mr. Rolneck, that is what I actually need, but I will also want to try to get my hands on as much of what would have been the OOTX data as possible. In general, you can never do any combination of electrical engineering, computer engineering, and computer science because there's too much overlap. But what you can do is you can get an undergraduate degree in one of those fields and then go back and get a master's degree in a different one. Somebody mentioned something about valves, though. Oh, is that a joke? Like a valve engineer? Like somebody who designs valves? Oh boy, GNU plot. Peter, if you can come up with the actual commands, that would be really cool. I don't know how to do what you're describing here. Yeah, if you can just get... Yeah, I don't know how to use GNU plot for that. If you can go... Can you make a gist on GitHub? That would be really helpful. So one of the things I'm going to do here is I'm including a if you don't get any data for a long time. And I'll show you guys why. The reason is, in the actual data set here, whoops, wrong one. The actual data set here, there are a lot of sections where there's just no data for a very, very long time. So like right here, there's a section of many, many FFs with just absolutely no light coming out of the laser. I guess that's probably when the laser's pointed away from you, but I don't really know what that is. Peter, I can't. Please. Can I actually run that? Yeah, I don't... What's going on? Let's try that again. Okay, let's try this whole thing again. Repaste it. Oh, come on, GNU plot. Grief, it froze.
It's pulling in lots of data.
Yeah, I don't think I'm going to be using GNU plot for this. I feel like every time I've been like in a situation where like somebody's like, oh, you could use GNU plot for this. I try it and it's like something about it is just bad. Like it just happened again. Someday I'll actually use GNU plot and it will be useful, but today it is not. Oh, come on.
How much data are you throwing at it?
Not sure.
Why don't you just kill all of them?
I hate kill all.
Why don't you just kill batch mechanism?
No! I'm just gonna do this the normal way. Well, that's concerning. Why would there be asymmetric shorts? There should never be asymmetric shorts. Maybe I don't understand this. Maybe it's when it first starts up? Pretty cool. It reverse engineers Lighthouse and doesn't afraid of anything. Oh. Thank you. That is, you are saying I'm not afraid of anything. I'm afraid of many things, but not lighthouses. I think lighthouses are amazing. Is this no, Peter? I don't see what you were saying. Oh, your blog site, Hervin Dervin. Is this it? No. Maybe? My gosh, you do some cool stuff yourself. Hey, Root! It's Root! Yay! Hi, Root. Root. Oh, so you just mostly just cleaned up the edges, and then, so that's the source data. So you're treating longs as zeros, shorts as ones. Looks legit. I guess what I'm concerned about right now is why would I ever get asymmetric shorts? So, like, maybe it's only after a really long one. Oh. Okay. So let me explain what I just noticed. It seems that right after the really long waits, let's see if I can find one here. So we have a really long wait, and then we get some data after it. And we actually have a short is the very first symbol here. So I guess that just means that it's probable that the data stream is just always sending, and we just happen to get it in the middle of the stream here. Justinic, no, Valve actually straight up sent me the lighthouses. I sent them a letter saying I'd be reverse engineering it live on YouTube, and if they didn't want me doing it, they shouldn't send the lighthouses. They sent them, so... I did sign a thing saying that they are still their lighthouses, so if they ever want them back, I have to send them back. Okay. So let's see here. Did we get any bad... We had 0 bad data. So that's pretty cool. Let's see what this data stream looks like. Actually, I wonder, has anybody ever actually taken a look at the underlying data stream yet? I think that would be kind of cool. I should have looked at how big that file was before I tried opening it. That is 11 meg. That should handle... Oh, but it has a... Whoa. Hello. Whoa. I don't know if you guys are seeing this clearly. There is a pattern here.
Just a tab.
Oh my gosh, yes. Okay. We're gonna go make this into a picture right now. Let's see, what would be the best way to do that? let's see. So it was 8 seconds, 50 hertz. That would be 50 times 8 is 400. So let's make it so it'd be 300 lines tall. Okay. File star ppm int main equals fopen test.ppm piece. Let's say 8192 wide. 300 high. Let's say 512 high. No, 300 high. That 17. What I did wrong? What did I did wrong? I forgot a semicolon somewhere. Probably shouldn't do that. I'll probably just write straight to the file. Let's do that. Did I do wrong? P5, new line, new line. Do I have to have a comment? Is that required? PNM loader expected to find an integer but didn't. Oh, that's PBM. PGM. Oh, new line. Whoopsies, forgot. The PGM file format, you have to say 255. And then it should be able to open. You know, Timid, if you want, you can totally use that to visualize the data. Swanky. Oh my gosh, look at this data. Oh wow. Beautiful indeed. I think I can tell which ones are the ones and zeros in the OOTX.
We should make a demo scene thing that zooms in and out of that and uses that as an effect.
You may if you want. I'm not. Oh. I wonder if there's a special code, like some sort of end of OOTX data.
If I had to guess, it would
I'd
be
say it's
the
probably that
short
right down there.
things.
If I rotate this and I cross my eyes, I should be able to see if there's a pattern. Okay, let's see here. Actually, I don't even see a pattern anyway. Yeah, no. Maybe I don't have enough data yet. Actually, we can record a little bit more. It doesn't necessarily only have to be 300. Let's see how many lines of data there are. Yeah, based on what Ben was saying, I was worried that it was going to end up looking like a troll face or something. Yay, more data. I like data. I don't see any repeating in the data stream, though. I also don't see anything other than exactly these two patterns, except for the very first one, because that doesn't really apply anyway. Does anyone else here see any sort of pattern going on? 'Cause I don't. So right now what we're trying to do is we're trying to reverse engineer the data that's coming out of Lighthouse 2.0, tracking lighthouses, the lighthouses that come from Valve for the Vive. And this is the data stream that is coming from the sync over beam signal. I am absolutely confused by this data stream. Hold on, let me reload. Okay, so the data goes, is the laser is scanning across. It basically goes starting here and going this way. And then the next line is after the break. How do you change it to a different differential channel? That's a really good idea, but how do you change the differential stream? Okay, we'll try it. How do I know what channel it'll be on?
Always somebody in my way.
So just press it once and hope, you say. Well, I pressed it once. We'll see what happens. We'll record about 800 megabytes of this. That's not good. It's a lot of bad data. Looks like the data streams are completely different between when you press the button and when you don't. I don't know, I'm really concerned though. 12s and 4s. It's like really bad data. Oh, you know what? I think I loaded... No. Still getting a lot of corrupt data. It's exactly like on the line. Oh, you know what it probably is? Probably just that very first event. Or not. I can't open my DMs live on stream. Sorry, Peter. If you want to do something like that, it can't. It's got to be like something I can publicly show. I don't have another screen I can move stuff if I want to be able to open things that aren't public. Oh, you know what? For this data set, it looks like it's the very last message that has a bad corrupted part. So that makes sense too, that's fine. So this probably is actually legit data. Oops. Okay, I think it is time for a recap because there are a lot of people watching now that weren't watching the whole time. So what we have is we have this open valve lighthouse right here, and we're tapping into the laser, whatever it is stuff. Come on, refocus. We're tapping into the where the laser turns on and off here at the top, and I wish this thing would just refocus. Come on. Whatever. And then we have it hooked up to this FX3 logic analyzer right here, and then that's going into my computer over USB 3, and I'm capturing that data, and with that captured data, I am then going through the stream and I am basically doing a differential Manchester decoding, which means, here actually I will pull up a picture here. Oops, actually, this is actually a pretty good one. This is from one of the people who are watching the stream, Peter. And what he has is anytime that there are long, so this is like the actual data that's coming out over the laser on the Vive stuff, and anytime that there's a long pulse, that's treated as a 0, and anytime that there's a short pulse, or a pair of short pulses rather, that's treated as a 1. So using this information right here, you can recover a sort of data stream of what's actually coming out of the Vive. And so what I'm doing is I'm plotting that data stream in a picture, starting like from over here and going in that direction. And the idea is each one of these lines is another time around the rotor. And then I'm comparing the two. So each of these have different Lighthouse beam IDs, so to speak. And so the idea is these two data streams differentiate with nothing other than a different beam ID. But it's clear that something else is going on because, like, the data that we have right here is totally different. It's not that there's just some one bit that's changed between these two streams. They're totally different streams. I mean, it looks like there are some common pieces between them, but not a lot. The Lighthouse 2.0 lighthouses don't need anything to sync with. They just don't care. So you know what I'm going to do? I'm going to extend this. Okay. Peter, also one of the things is that the lighthouse, when it's inside of its container, the shell itself warps the beam. Oh, okay. So Justinic, the reason that you do the sync on beam, isn't because it will sync with something else, but rather when there's something passive just like sitting out there listening and it needs to know what angle it's at, it can look at the data stream and know its angle from that. Yes, and Jamie, that is dead right. And Worms, I don't think that's the case, but I'm about to go upload both of these things and we'll see what they both look like. Uh-oh. The width of the image is based off of the distance. So, if you look at this data set here, give me a moment. There are sections where the lighthouse sends a whole bunch of FFs in a row, like right here, which means that the laser's just off. And the idea is I just reset to the beginning of the line as soon as I see that. Ah, okay, so Chad, the thing that we're trying to do right here is make it so that we no longer need the whole valve hardware kit, or the whole triad thing for that matter. Instead, just use the chiclets with a completely different system. This makes it possible to do all sorts of absolutely weird and crazy, wacky projects, because now you no longer need all of the support framework to go use Lighthouse tracking. There's a lot more data to the image width than I was prepared for. Huh. So right now I'm playing a little game of Clue to figure out where the highest data point is. Like how wide would I actually have to make it? So it looks like there are 113, 214 bits per sweep. Oh boy, a lot of people have a lot of questions here. Tell you what, I'll upload both of these raw data chunks right now. First of all, though, I do want to see... Whoa, did not mean to do that. Let's see, is it even possible to open this up again? Well, I'll be darned. That is impressive. Apparently GIMP can open files that are 113,000 pixels wide. Ooh, you know what I want to know is if something... Should not have saved it. Maybe it'll work. I don't understand the question about the whole splitting it up into gaps. So right now, Continuum, I don't have my TS4231 hooked up and capturing data. I should do that at some point soon, but not right now. I really want to just try to get some of this data stream decoded. I don't understand what you're saying, Peter. I mean, I could do that, but I don't know what it would buy me. One, do you think that there might be some sort of repeating pattern within the Manchester coded data within a line? That actually seems like a plausible thing. I'm just trying to make these both streams, and then I'm going to go upload them. Oh, I see what you're saying. I think that maybe some of the bits are the same. So here's what my guess is that he probably is using somehow like the Lighthouse ID to like seed a pseudo-random number generator, so that he'll just happen to know which Lighthouse it is or what data is being sent based off of the what would appear to just be pseudo-random noise. But that's just my guess. So let's see. I'm just trying to get you guys some data here to work with. Peter, I don't think it'd be that inconvenient. I mean, yeah, I guess it kind of would be that inconvenient, but because that would mean that we would just have to like store the whole stream. But there's probably some pattern to it that we'll find. That is, yeah. I mean, like right now, like anything is possible. I mean, we only have half an hour. Ooh, we don't even have half an hour left in this run before I gotta duck out. Yeah, I'm really glad there's no preamble. That would just be, forget this noise then. Because like you're just going to be getting data in the middle of a data stream. You got to decode it like right then. Okay, I have some new data up. I hope you guys go have some fun with this. We'll still keep poking around for the rest of the stream right now, but I don't know, maybe we'll get somewhere. Okay, so I think the next thing that we should probably do right now is open up this PPM in something we can look at the individual bits with. Let's see if we see a pattern to it. Looks pretty random to me. So what we're looking for is some sort of sync marking, something that's repeated every number of bits. I am not seeing anything at all like that. Does anybody know if there's an easy way of running an FFT on data like this? I do not see any image appearing. I'm pretty sure we're already past 50. We are right now at 60. Yeah, if the FFT shows that there's no pattern, then you know that there's no pattern. Although I almost have half a mind to think that like it's somewhere in here there's just gonna be like a picture of Alan's face laughing at us. Right now, yes, this output is encoded 1 bit per byte. Yeah, I'm just highlighting everywhere that there's a 2 shorts in a row. The 2 shorts are encoded as a single bit. Ugh. Actually, you know what I can do? You can do an FFT in GIMP, can't you? Man, GIMP totally needs a feature like Blender does, where you just start typing what you want, and it's like, oh yeah, it's that. Okay, MCD, go fire it up. Do whatever you want to do. Ah, but LV, what the FFT will tell us is whether or not this data really is random. And that is correct, Emil. I don't do NumPy, but you know what I'll just do? FFTW example. that's a good point. I should be doing autocorrelation. How do you do that? I don't even remember. Well, actually, you know, an FFT would still tell us that there is repeating patterns, but an autocorrelation would be an interesting move. Let me do this first, and then we'll play with it. Dot real? Is that how that works? How do you write to the data? Oh, people just aren't talking. I thought people, like, something was wrong with the chat system. Does anybody in chat know how to actually access the data inside of one of these things? I don't understand what you mean by the bars separating it into individual sweeps. Each line is its own sweep. How would the y-axis be the data? Right now the y-axis is the sweep. Mr. Ralnick, I uploaded it in the GitHub issue. Wait, Brittany, is that last B the Brittany I think it is? The data is right here. I have 5 minutes left before I have to go. I'm really hoping to at least get an FFT of this before then. Great. Can somebody... Man, why am I not... Uh, Sharukuk, I really don't have enough time to test that right now, but if you can, that would be awesome. Data looks pretty trashy to me. How do I... We can kind of infer the angular resolution of the lighthouse from some of the information here. So, for instance, we know that it's 113.214 bits per revolution, but there's still a dead zone. So probably on the order of 120,000 bits per revolution. And you could probably get sub-bit precision. So, at least you would probably be able to get under... You could probably get about 1 millidegree. Okay, seriously, where... How do you use RFFT 1? I don't even know. Sorry guys, I gotta go. We should totally take a look at this a little bit more later. I think the autocorrelation thing is a neat idea. Probably shouldn't even be doing FFTs for that. We could just do it in straight C. Why didn't I just think to do this in C? This is just too much work trying to get FFTW up and running. There's no reason it doesn't have to be fast. Actually, can we just do it in C real fast? Is that a thing? Hey Adam, you want to go to church? Never know if he hears me or not when he plays boats. Actually, there's another thing we can do to look at the file for entropy. That's not that hard to do. I would say that the file is very, very entropic. Entropic? Because the ppm is, well, no, maybe it's not. It's a little over 10 times as big as the PNG, so there may be some form of entropy there. I don't know, guys, but it sounds like you guys are on your way to do some interesting stuff with this. I am going to have to start taking my leave real soon. What I'll do is zip these two up. Yes. Yes, Pearlmonger. So I'm actually writing a really quick and dirty autocorrelator here. Let's just see what it says. Adam, church?
Yes.
Okay.
It might be a while.
Oh, okay. I mean, I'm still streaming, so as soon as you're done, I'm just closing the stream. Which is not allowed. Okay, so I'm basically using an autocorrelator here, and I see virtually no correlation anywhere in the file at all. So, yeah. Let's go with there is no correlation. I understand it gives a vector where it peaks. I don't see any peaks in this file. If there was a peak, it would be massive. All of the numbers here are tiny. Maybe I'm doing something wrong, but Yeah, I would expect there to be a massive peak somewhere. It would apply probably pseudo-random data. Let's see what the most correlated thing is. I don't really understand that. Maybe my autocorrelation isn't right. It should be centered around 0, not around some massive number. Unless there's an offset. I wonder if there's more 1s than 0s. Yeah, let's find out. I don't know if he was necessarily efficient about how the information was decoded. He might be. But keep in mind that if all he used was a pseudo-random stream that had really good properties of non-repeating like patterns, then it'll look like random data, and it still tells you exactly where you need to be, or where you are. I'll be darned. It does not have more 1s than 0s. Okay, well, we'll have to go deal with this some other time now. Data... FX3 process 2.c, git commit, bump more mal tools. Okay, thanks everybody for tuning in. All of the data that we are playing with is available on the link that I provided here, as well as on the GitHub issue. Ooh, looks like somebody else has been commenting. That's neat. Wait a minute. Are you serious? Are you serious, Root? You figured it out? Why didn't you say this in chat? What? Okay, well, I'm going to have to go read this tonight. I urge everybody who's watching right now, please go to this issue right here, and clearly Root is a far better signals guy than I am. Wow. Okay. Well, I am checking out, but see you guys. You want the link? Yeah, that's pretty wild. Okay.